Hey, what is up guys? Last time we did a lock direction on our jump, so we cannot move from left to right while we're jumping. This time we're gonna do a wall jump, and it's actually quite simple. It's not too hard to understand, but we're gonna be using some new stuff. So make sure you're ready. We're gonna create a level that supports that wall jump. So I'm just going to extend this cube, not 51 to 5, and I'll move it over here. So now we have a nice wall we can jump on. Okay, go ahead and open up the player script, and in there we are going to declare a new callback function. So pretty much here we have a start that is being called automatically when the game starts and our object is there. We have an update which is being called every frame again automatically if our object is there. And now we're going to declare another function, make this a private void, and this one is going to be called automatically whenever our character collider, the green capsule, hits something. So make sure you do no mistake in this. If you do any kind of mistakes in this function call, like if you forget a capital letter like this, it's not going to work. So make sure you have no mistake in this. And also it takes in the parameter a I think it takes in a controller collider hit over here, and we'll call this one hit. Okay, so again, let's test this out just to make sure that everything works fine and we have written our function like we're supposed to. Let's make a debug.log and we'll say we've hit something. Now this function is supposed to be called every time we enter a collision with something, so it's not happening, so I'm probably have a mistake in that. Alright, let's go back in our code. Okay, so small mistake on my part. It's supposed to be on controller collider hit, not on collider controller hit. So I just inverse these two. Make sure you write it properly, and then let's test it again. Press play. And as you can see, now we're in collision with the floor. It says we've hit something. Same thing when we're in collision with the walls. And yeah, so this is pretty much working. Now this function is going to be quite useful for a lot of things. A little bit later on we'll do collectible, and this is going to be able to tell us which collectible we've entered collision with, because as you can see over here we are taking a parameter in this very function. So this thing here that we name hit has information on what we've just hit, and let's just show that again. So we'll do a debug.log, then hit, and we can get pretty much all the information we want from whatever we're entering collision with. So say hit.game.name, gameObject.name, we'll do that just for test purpose. Quit. Now in game, if we go here, as you can see we're entering collision with cube. I'll do collapse, and now if we move over there, we enter collision with cube number 3, which is this one. And we were entering collision with cube, which was this one. Okay, so now we know that this has information of where our collision have happened and what object we entered collision with. We're going to be able to use that to make a wall jump. Now how exactly are we going to do that? We are going to take the controller, our character controller, and this one has a really nice condition, and I'll just show you. So type in a if, and then we'll do controller.collisionFlags is equal to collisionFlags.sides, like this. Now let me explain to you what this does. Controller.collisionFlag is a value that pretty much keeps the information of where exactly are we having collision right now, on my sides, on my back, on my they call it above and below. So pretty much you can know where exactly the capsule collider we're using or the character controller we're using is having collision from. So right now we're testing, are you having a collision with the sides? So are you touching something on the sides of your capsule? If yes, then we run something, say debug.drawRay. We're going to draw a ray from hit.point, and hit.point, if we read this real quick, it says the impact point in the world space. So it's going to show you exactly where the collision is taking place. And then we need the direction for that, so we'll say hit.normal. This is the normal of the surface we collided with in world space again. And you're going to understand what this does in a really short moment when we actually draw that ray. Now I'll give it a color, so color.red, and a duration of 2 seconds. Okay, let's try this out. So we're in our game over here. Nothing happens when we're colliding with that cube, and the reason is, it's because we are not colliding with the sides. This function is being ran, but it does not enter in the if statement, because we're not colliding with the sides. Now, as soon as we do hit as soon as we do enter this if, we're going to draw a ray from the collision point using the collision normal. It's going to be a red ray, and it's going to last for 2 seconds. So let's try this out. Oh, okay, so there's actually a ray being drawn, but we don't know. As you can see in the scene view, we can see it, but in the game view we can't. So make sure you turn on the gizmo up here. It's going to pretty much show you the same thing you have in the scene. So now let's try that again. And as you can see, it's drawing a ray starting from the hit point to the normal of that very surface we've hit. Now, what exactly is the normal of that surface? The normal of that is the direction in which this face over here, this quad, is pointing. Now, if I was to move this a little bit, just a little small rotation like that, and we were to enter collision with that again, just to show you, you can see that the normal of that face has changed because this is not facing in the same direction. Just imagine a ray coming straight out of your quad with two 90 degrees angles, so 90 degrees on the z-axis and on the y-axis. Now this is going to be quite useful when we want to do a wall jump because it is going to give us the perfect ray for a bouncing motion. Now we're just going to modify it a little bit because if we were to just enter in collision with this, it would look like that. So simply going in this motion. Now we don't really want this. What we'd like to do instead is have a motion like this when we jump again. So we start from the bottom, we jump here, then a wall jump like that, so we gain some height. And we are going to do just that. But first, let's make sure that this, the inner of that if, is only being called when we decide to jump again. And to do that, I'll simply use the if get key down spacebar that we made before. So we're only going to wall jump if we press space while we are colliding with sides. So actually I'm going to leave the ray in there so we can see it in game. And yep, so that's pretty much it. Now let's do last motion is equal to hit.normal. So we now adopt the normal of the surface we've hit in the last motion. Now assuming we're in the air, we're not going to be able to move left to right, and this move vector.x is going to use the last motion.x, which is now the hit normal.x. But less talking, let's go look at what it does in game. Okay, so this is pretty much not working right now. Let's go test out some other stuff. Okay, so small mistake here on my part. We're going to do move vector is equal to hit.normal instead. And now we need to give it some kind of force. So hit normal is a unitary vector, so it's only of length 1. But we move faster than 1. As you can see here, speed is 5, so we're going to use speed actually. We're going to go ahead and say hit normal times speed. So this is going to give us a 5 meter motion vector. Now after that, we're also going to modify the y of that very motion vector for, say, jump force, which we don't have, and I think we're going to implement it right now, but our jump force is 10, because over here, in vertical velocity, we put 10. Same thing here. So I'll go up here and I'll do a private float jump force that is equal to 10. Now we're going to replace wherever we enter that information in a hard-coded way, so where we directly type in the code 10. So where it says vertical velocity is now equal to jump force. same thing over here, and same thing down here in our new function. Now let's go see in game what we get. As you can see, we get a nice bouncing effect from that wall, and that's exactly what we want. We could also reset the second jump or the double jump by simply typing in here double jump. Wait, how did we call that already? We called it second jump available. So we'll just say second jump available is now equal to true. Nice. Okay, one more thing that we need to fix in a future episode is the isGrounded function from Unity is based on physics. So sometime you're trying to jump and you're not actually jumping. It's because there's a little you pretty much jump on the wrong frame and the physics didn't think that you were grounded. So we're going to fix that a little bit later on using our very own grounded function, but for now we'll deal with that. And now we're jumping on the wall. We should be able to double jump right after, and as you can see it works. So jump and double jump. Good. So that's pretty much it for this episode, guys. Thanks for watching. If you have any questions, please leave them in the comment section below. Also, if you thought that this was helpful to you, please leave it a like, and I will see you next time.